Hello, and this is lesson 4. In the previous lesson, we have discussed what are these key tools that can support us in our daily digital marketing routines to really help us do a better job in choosing the right ad categories, in do a more effective targeting, to get a better relevance score, and to really consider and take care of all those cost factors that affect the cost of our ads. We mentioned that actually many of these tools, if not all of them, are based on AI. But how does AI work? And is it magic? Is it those magic robots, in the pictures we used to see, or it's like a big brain of doing things? Or is something actually different? Maybe it's not even magic. We're gonna discuss this in this lesson. And the lesson name is How Does the AI Magic Work? So we're gonna talk about collecting some pixels into bags. Pixels into bags? Yeah, I wrote that. Yeah, pixels into bags. Yeah, we'll be collecting pixels into bags in this lesson. We will be also distinguishing cats and dogs. Yeah, that's what we do every day. Yeah, right. That's what AI people do every day, distinguishing cats and dogs. We will be getting more insights when Facebook's servers are down. Are they down? Oh yeah, it appears to be sometimes they are down. And we will be getting insights from Facebook when their servers are down. Interested? Okay, let's proceed. So let's look at this gentleman. He's James Pennebaker. He has created the dictionary called LIWC, Linguistic Inquiry and Word Count. Basically, it's a dictionary that tell us that people of different personalities use different words. Like I will be different, using different words as compared to my neighbor who is more introversial than I. And for example, he found that leaders use word I much less often than followers. Followers use word I, leaders use word we, and many, many other things. The multiple versions of the dictionary he has created have grown from 70 categories to a bigger number of categories into the hierarchy. So the recent version of the dictionary is quite comprehensive. And it's really very useful for some machine learning and AI stuff, which I'm going to explain. So for now, you just need to know he created a dictionary that maps personality types into different types of words. And this dictionary can be used to represent the data. So if you have extrovert and introvert, their personality will be different, right? And then the word distribution, as you can see in the picture, will be also different for introvert and extrovert. Introvert might be focused on the spikes on the left side, let's say function words, verbs, and then extrovert will be focused on some unique words and question marks, etc., etc. This is just for the sake of example, okay? It doesn't mean that this particular categories differentiate introverts, extroverts, but I hope you start understand how does this dictionary approach works when it comes to LIWC. So this is a way to represent the data. This is a way to represent the textual data, just like a distribution of the words. But when it comes to the visual data, how visual data can be represented? Okay, let's just go into very basic idea. Let's say we have a 16 to 16 square window, and we can compute so-called edge orientation. So look at my face. I have this edge, this edge, this edge, this edge, this edge. I have ears, they also form the edges, the shape around my hand. Everything around me is all edges, and I also have these edges and these edges of my column and my shoulders. It's all edges. And these are all very distinct descriptive factors of an image of me looking at you that can differentiate me, from example, from a dog, from another humans, from other objects. So for a computer, it's a task to differentiate the door behind me and myself. They need to put effort. and need to find feature descriptors to differentiate human from the interior design feature like a door or wall or a switcher, etc. So we can represent each image as a distribution of these edges, just like in the picture you can see. And these edges are scale invariant and also rotation invariant. So you can change your picture, you can change my hand in this way or in this way, and it will be still the same edges, right? So it still will be my face. So this is called SIFT features, and this SIFT features is one of the common ways to represent the image data. So the text data can be represented as a word counts or as a dictionaries, like James Pennebaker have invented, and the image data can be represented of vectors of these edges, right? So it's called angle histogram. And this angle histogram basically shows in every part of the image, in every square of the image of the 16 to 16 pixels or whatever window you choose, there will be a certain edge orientations, and this edge orientation will define what is inside that part. And this is scale and rotation invariant. And just a short remark, the same thing get done by convolutional neural networks. It's just in convolutional neural networks figure out these patterns by themselves via convolutions. And here we explicitly define that our features, our data representation has to be these edges. But idea is the same, right? It's just the next step. So once we have these edges, we can group them into objects. You can see it's kind of a bag of visual words, right? So that's why I say we're gonna collect pixels into bags. And the right side is a bag and the left side is an image with the pixels. And if you group these edges into groups, you can actually see that there is one group belong to eyes, another to the roof, another to the window, another to the stairs, another to, let's say, eye of an uncle with glasses. And this is called bag of visual words. So if in case of text, we had the bag of textual words, right? Like a real words, actual bag of words where we computed the word counts for different categories or just overall the word counts. Here we have a bag of visual words. And these words are pretty much objects inside the images. So we have an image represented as different objects in it. And in text, we have text represented as counts of different types of words. So when it comes to SIFT descriptors, it's pretty much quite a common strategy and quite a common technique that is used in machine learning. And once you use this bag of visual words and detect this kind of words, the clusters of these objects, you can do a further step and do this kind of visual object categorization algorithms, or it's called also concept detection, where we can have an image, and inside this image we have sky, stated tree, stated people, stairs, tree, basically objects everywhere in the image. So what we can understand from it, we can kind of have a bit of human cognitive perception of the content. We no longer see it as a pixels, but see it as an object, as a holistic and a little bit more abstract way. We can see what is inside there. There's a statue, there's a bunny, there's a people, many, many other things. And when we look at text, we don't just look for the letters, we don't look even for words, but we look for categories. These people are more introverted, these are more extroverted. These words are talking about, let's say, politics, and this bunch of words are talking about let's say, automobile industry. Another one is about fashion industry, right? Topic modeling is another technique. A key point here is to make AI algorithms run, we need to represent any type of data as a fixed size vector of features. And it can be textual features, let's say our words counts or our category counts for LIWC, and also image features or visual features. Why visual and image is the same? Because videos are pretty much a sequence of keyframes, right? So it's still images, right, to us. And same can be done with sound, because sound is a certain audio spectrum that can be decomposed with a fast Fourier transform or whatever techniques. We can also use location distribution, where people go to, and etc. etc. Can we go very deep? Okay, I can explain this in more details maybe in another course, but this is the core idea. Data needs to be represented for every modality and need to be put in like a buckets. And once it's represented, AI algorithms can work with it. So let's discuss one of the simplest AI algorithm or machine learning algorithm called K-nearest neighbor classifier. That's why it's called KNN. You know, you'll see how damn simple this algorithm is and how simple AI can be. And you know, most of other things that AI algorithms are doing have pretty much similar principles. They're just more complex functions, but they all do the same. So don't be afraid. My main objective is to show you how simple AI is, and it's not a rocket science at all. So how it works graphically. We have two classes, class green and class orange. And this is our training set. We know about this, each of these dots, whether it's green or orange, you know, right? We can see that it's orange and green. We also have them in the 2D space, right? We can understand that they all have two dimensions, which is y and also x, and they are aligned in these two dimensions. So we can actually tell where the orange dots are and where the green dots are. But now we're getting a new test data point. So now we have to do AI inference, AI prediction. We have to do this magic because we don't know whether this test data point belongs to green class or to orange class. Or let's say green can be dogs and orange can be cats. So we don't know whether this new data point is dog or cat. So how we can predict it? Here is the data representation come in. So let's say our 2-dimension is the representation of the topics and also representation of the visual, right? Let's say just really simplify. So we have textual here and visual here. So we try to figure out how close our new data point to other data points around. How close our data point to each of the dogs class, of each of the green class, and how close it to each of the orange class. And we can see that most of the neighbors of these data points, k neighbors, so k is equal to 5, right? We're looking for 5 neighbors, is green, is dogs, are dogs, right? So what will be our conclusion? Our conclusion is that our data point is also dog. And this is what is happening every time when the AI inference works. So there's a good example here. So, and also there's a big advantage of this algorithm. It's first extremely simple and it's easy to compute, but another big advantage is that this algorithm also belongs to so-called online learning, where this AI learns in real time, learns online. Every time we are getting more points into the system, into our training set, and we know their labels. Let's say we know they're dogs or cats. Our algorithm can infer information from different neighbors if they are close to our new test point, and our inference results can improve every time. So system learns with every new data point coming into the training set. We don't need to retrain it every time. We continuously learn. This is like a real true AI. And you know, you'll be surprised. This algorithm quite used in quite a bit of industry application because it's fast, because it's relatively easy to implement, because it's online learning algorithm. So, and this is AI. Is this rocket science? Probably not. Whether it's much simpler than other AI algorithms? Yes, it is much simpler than other AI algorithms that are used in many state-of-the-art systems like Facebook and Google. But idea is the same. And as long as you understand this, you probably will be a little bit less worried that AI gonna tackle the world, but you can more focus on how AI systems actually can help you to do a much better job in your, for example, daily marketing routines, but also in the whole of your life, right? So when Facebook break down, what is this Facebook breakdown and what has happened? Actually, this is not a secret. Facebook sometimes get indeed breakdown. So you log in Facebook and you don't see any content. It could be because the servers detached and you cannot upload the content, or maybe they rolling out some big update. It's fine. As a big company, it happens. What is interesting for us is that Facebook annotate each and every our content by the set of objects inside this content. You can see the first image has a night, sky, and outdoor, and second one have flower, and the third one have tree, sky, outdoor, and nature, and the next one have people standing, and the next one have one more people sitting, and continue. We have more on this. So this is information that Facebook AI algorithm, just like this one, just like KNN, just a little bit more complex and larger scale, predicts what is inside the content every time we upload. And every time we upload this content, Facebook reiterates on what we are interested in. Every time we like, Facebook reiterates what kind of objects on the piece that we like, and then reiterates on what is our interest assigned to us. So this is quite important concept, and this happens 24 hours, 7 days per week, continuously happens. And this is something that really affects the cost of our ads, right? So this is how it works, and this is what really happening in all the big data systems like Facebook and Google. And when it breaks down, we can see what is internal. The Facebook ads are partially and pretty heavily dependent on this kind of category that Facebook predicts. So if you open your Facebook privacy tab and see which categories of ad targeting are assigned to you, sometimes you might find that some of these categories are really very interesting because they actually get assigned to you not even from your browsing history, but can be from a history of your friends and family. So this is just one more example. The guy took a picture of himself. Then during the Facebook breakdown, he found out that Facebook have counted himself and also all the people around him on the picture, right? The famous arts piece with apostles. So they count him one of them inside the picture. And it was happening also during the Facebook breakdown. So he had the opportunity to actually see what's going on. Again, he tweeted there. And somebody else also posted on his Twitter profile other pictures from Facebook that it containing people and have shoes inside there, people smiling, people standing indoor, and there's a child, and there's indoor activities, etc., etc. So all these are results of billions of inference procedures that Facebook makes every time we can post any content, interact, do any action inside their ecosystem. Of course, the same thing works in the facial recognition side. Remember, I was showing that I have these edges of my face. So actually, Facebook and pretty much any other recognition systems are trained in this way. They are trained to have two faces and match these faces and predict whether it's the same person or not. And if it's the same person, then system get trained to predict the same person. If it's different people, then they're trained to differentiate these two people features. And the features I use can be SIFT, can be some deep learning features, but idea is again the same. Data get represented. Face get represented the sequence of edges, and then this data get fit into some model like k-nearest neighbor classifier or some deep learning network, and then the faces can differentiate. And this technology constantly work on Facebook. Every time we upload the content with our face inside, it performs hundreds of thousands of operations to match us to all our friends, all our previous content to detect our face, and then it tells you, give you a suggestion. Okay, do you want to tag yourself? And when you tag yourself, Facebook algorithms really learn, okay, this time it was correct. So the classifier start learning so to do a much better job, and the next time it will be matching. So how it works. The results of the Facebook at work can also be seen from the browsing habits tab inside the Facebook analytics dashboards, right? From the audience insights dashboard, you can see that There are top categories of for people that like particular page where they browse. So I'm showing you this example, and this example of analytics for Burger King, basically to show you that Facebook not just tap into interest, but they also look for particular network connection between people, like a graph, and seeing who is connected with what, who is visiting which pages, and based on that, it also infer the interest for targeting for people. What it also means for you, it also means to you that not always Facebook is right in detecting your interests, and then when you let's say target burgers on Facebook, it doesn't necessarily guarantee that all people who will be watching your ad will like burgers. Most likely it will guarantee that some of them like burgers and some of them just somehow get mapped into burgers. So again, how to find the whole variety of categories that's really relevant to your content, really discover your target audience and market to them efficiently. You need all this AI and tools to really help you with that. And if you look overall into the ecosystem of Google's and Facebook of our world, you can see that AdWords incorporates smart bidding strategy to do a better job in terms of marketing AI, right? When you enable the auto bidding strategy in Google and Facebook and AdWords, you'll see that actually Facebook AI predicts how likely this particular guy gonna benefit from ad you're showing, and also considers the relevant score. It starts bidding for particular impression, consuming the likelihood that this guy will respond to you according to the whole history of this person before on which kind of ad the person was reacting. This requires a real-time AI system, and it's personalized AI because it's personalized for every particular individual, and it can be done with Kaizen classifier. So you can see in your history, you can see what type of ads you responded. You can detect the probability of how likely you respond this particular ads, and the bidding will happen automatically. That's what happened when you do this lowest cost bidding and automatic bidding strategy. This is AI tool. Then what happens in YouTube? YouTube save content, use machine learning to detect whether this content is actually appropriate or not, or whether it has to be banned immediately. Maybe there's a porn inside there. Maybe there is some hatery speech inside there, so you don't want to show that. Maybe comments are not good, so you want to remove these comments automatically. You don't want to show them. It uses a lot of natural language processing and AI to predict that. How it's used. Again, you can use your KNN classifier, and you can represent your textual data and content or visual data on the video itself. You can train a model that will be porn, non-porn, hate speech in text or not hate speech, and then this classifier can give you a probability that there's a hate speech in particular post. You can run automatically through millions of posts and really predict that, and that's what YouTube is doing. What can be done in Google Photos? Google Photos suggests people you want to tag. So it's a facial recognition, the way I just explained in the previous slide. And then Gmail gives you smart replies. So this one is pretty much content recommendation or content generation feature, where AI generate content based on the billions of messages that has been sent through Gmail. They generate some possible endings of your phrase based on what you people like you and you typically want to write. So it helps you to write your message faster in a proper English. And I guess this and also Grammarly technology is pretty much about the generative and also content technology, generative content AI, as well as AI recommendation systems. So you now know how this works on the backend of many systems like Google. You now also know how does AI not so magic works, and I hope that now you can use this AI, use this understanding to do better pitches, to do a better understanding, to see what's happening in these big data systems, and have some explanation what is changing in this changing AI world and social media world. I also hope that it can help you to figure out the best use of the tools I explained, and also other numerous tools available out there in the internet. But how does this get applied in the real world? How can this all be used to enhance your digital marketing projects, to really transform the industry, to have a much more holistic view of what's going on in these billions of data points, iterating every minute on social media. About this, we will be talking in the next lesson, lesson 5.